Alright, so number 12 is looking to, first of all, find the standard form for this hyperbola. And the reason why this is a hyperbola that you can see, that you need to know for the test, so this is review day as well, is that I have an x squared and then I have two y squareds. But the biggest key is that this subtraction that's happening between the two says that this is going to be a hyperbola. Because a hyperbola, order matters. There's subtraction. And you, please pull out your green formula charts as we go through this, because that's going to be huge. Thank you for those of you who already have it out. This is going to be huge as far as to review and know what I'm talking about. For ellipses, it's the size that matters. Is it bigger y-wise or bigger x-wise? And that's always going to be plus. Okay? So I'm helping you understand the formula charts as we go through. Alright. So I see the x squared, but I don't see an x. So I'm not going to complete the square with any x's whatsoever. I'm just going to complete it with y's. And before I do that, I'm going to GCF and move stuff that you know how to do that we talked about already from completing the square. I'm changing these y's by taking out a negative 16 that they have in common. Okay, so when I take them out, what's left over inside the parentheses? You tell me. Y squared minus 2y, and then leave a space for completing the square. This is very important right now, what I'm about to show you. That's a negative 2y, because if you were to redistribute, you would get a positive 32. That's a huge negative mistake that if you make it right there, everything is going to be wrong. Okay? So, now I have my completing the square piece that I know from a standard quadratic form that I'm going to look at the b term, whoops, and just divide by 2. So whatever b is, I'm going to divide by 2 and then square it. What's b in what you see right now? What number? It's negative 2, right? So if I do negative 2 divided by 2, just disregard the negative, I'm going to get 1. And if I square it, I'm still going to get what? 1. So that goes right here. Now, I just tipped the scale. Like I told you before, imagine this equal sign is like the middle part of a seesaw. I either added to the left just now with what I did, or I subtracted on the left side. You with me? What is it that I did? I didn't add. Even though this looks like adding, I actually didn't add one. I subtracted 16. You with me? That negative 16 coefficient multiplies and distributes with that positive 1 to show that I just subtracted 16 on the left side. So what you do to one side, you must do to the other to balance it back. Are we good? Okay. So now we have 9x squared. We have this negative 16. We have this parentheses, square root the last, borrow the first sign, and make it squared. Okay? And what do I get on the right side? What's 160 minus 16? 144. Now, does this right now, what I have it in the form, does it look like your formula charts? Does it look like a hyperbola? Yes or no? No. Because of what number? What number up here makes it not look like a hyperbola right now? 144. 144 must equal what? 1. So guess what we're going to do? We're going to divide all of these pieces by 144 to get this to 1 and see what these reduce to. So in your calculator, please put control divide, put 16 over 144, and then put 9 over 144, and let's see what those reduce to. They should be x squared over 16. This 9 over 144 reduces to 1/16. And the 1644 reduces to 9. And now we have our standard form, similar to what we see on our formula chart. Now we can dissect this and go through all of these steps, but this is step 1, just to be able to go through all these steps. Okay? So, can anyone tell me what the center is? 0, 1. Yep, 0, 1. Because it's going to be opposites of those signs in parentheses. Okay? What is A? find C. Guys, here's the thing. A, B, and C, how many of these pieces will you be given to be able to solve for the other one? 2. So I'm given A and B. Chances are now I'm going to solve for C. This is a hyperbola, which we know is subtraction. So to solve for C, I'm going to do what? A squared plus B squared. I'm going to add. I'm going to do the opposite of whatever this is to solve for C. So let's take these A and B values. So it would be 4 squared plus 3 squared. Can someone tell me what C is going to look like? 5. It's a 3, 4, 5 right triangle. So C is 5. Here's where I suggest you should start sketching some. You should start looking at what is this graph going to look like so that you can get all the other pieces very easily by a picture. So here we go. The center is 0, 1. A is x. So 4 units to the right and 4 units to the left. So this is 0, 1. What would these values be? Negative 4, 1. 4, exactly. So 4, 1. Left and right, 4 units. How many up and down? 3. So here and here. Let's do the top one. What's this coordinate point going to be? 0, 4. And this one? 0, negative 2. Anyway, so these are our and I'm recording. These are our vertices, and now C is going to be 5 units. Now here's the thing. C is 5 units that will either go up 5 units, up and down, or it'll go left and right 5 units. Which one do you think it's going to be for this particular problem? It's going to be left and right. From our equation that we got way down here, which one was positive, the x or the y? X. And with hyperbolas, order matters. So it's the one that you write down first, or it's the positive one. You with me? The reason why I say that, guys, is this. Look, if on the test you see something that looks like this, let's say 100, is this a horizontal or is this a vertical hyperbola? This is horizontal. Even though the y is listed first, order matters means which one is positive, which one has that positive coefficient. That's what will tell you that it's going to be horizontal. So it would be something like this. And I just created this problem just so you could see it doesn't matter necessarily what's listed first. I mean, it does, because most likely you're going to see something positive minus the other one. Okay? Questions? Okay, so let's keep going. So the vertices, we know the lower vertice is going to be negative 4, 1. The higher is going to be 4, 1. Because it's horizontal. Okay? So it is going to look something like this. Okay? As far as that square or that box is concerned, it's going to look something like this. Oh, that was fat. So you'll have lines, which are those asymptotes that will go through those corners of those boxes. These are those rise over run pieces, if you will. And it'll look something like this. Ish. Okay? And finally, C. We said C was 5. So that's going to be here. What do you think this point is for the foci, or the focus? Negative 5, 1. And then this one? 5, 1. See, the negative 5, 1 and 5, 1. The graph does help a lot for you to start organizing all your pieces. Okay? And then your last one, your asymptotes. I want you to get y all by itself for both of them, for the negative slope and for the positive slope. So this negative slope here is going to be for this one, and the positive slope here is going to be for this one. And this is from Algebra 2 that we remember as the point slope formula, which is y minus y1 equals m times x minus x1. But in this unit, x1 is h and k because they come from here. My x value for the center is 0, and my y value from the center is 1. Can someone tell me what gives me that value? So m is what? Slope? Okay, we've also learned this year that slope is y over x, sine over cosine. What did we learn this unit? What letters does y and x represent? B and A, right? So B over A. So this right here, don't let this confuse you. This slope is now plus or minus rise over run. Y over x, B over A. Okay? We know B is 3. We know A is 4. So if I replace those, we're going to have a plus or minus 3/4. Okay? H is 0. So this goes away because x minus 0 is still 0. And then we have k is 1. If it was a negative 1, it'd be minus a negative, and we'd end up adding. But we're just going to do minus 1. And see, y is all by itself right here. So what we're going to do is we're going to move this plus 1. So we have plus or minus 3/4 x plus 1. You would do the positive 3/4 x plus 1 here. And you do, oh, I have those backwards. The negative here, and then the positive. You don't have to write positive. You could just put 3/4 x plus 1. And that's how you get this. Questions? Cool. So there's one.